In networking, a protocol is a set of rules for formatting and processing data. Network protocols are like a common language for computers. Computers follow standard protocols to communicate, and there are many, but for any system design interview, there are just 3 protocols you need to know: IP, TCP, and HTTP. When a machine sends data to another machine, it is sent in the form of IP packet. Think of IP packets as fundamental unit of data stored in bytes and has 2 main sections: IP header and IP version. IP header contains information about the packet, such as source IP address, the destination IP address the packet needs to go, and the packet size. IP version could be IPv4 and IPv6 and so on. The rest of the IP packet is data, and this is where the information one machine is trying to send to another machine is stored. The size of IP packet is however limited, typically around 0.065 MB to be precise. So if you are trying to send an email, let's say with some pictures attached, it needs to fit into multiple IP packets. Now when you send all these IP packets, you must guarantee the order in which they are being sent, so that the receiver gets the data in correct structure and take care of any lost packets. This is where TCP comes into play, which builds on top of IP protocol. It pretty much guarantees 2 things. The IP packets are sent in an ordered way, and all packets gets received by the destination machine without being damaged. TCP is virtually used in all web applications as it allows us to send long pieces of data which IP cannot do it on its own. To stitch together all the IP packets, each IP packet will have a TCP header, which means data section. So, when a client machine such as browser wants to communicate with the Amazon website servers, it first needs to create a TCP connection. And this process of initially setting up the connection is known as handshake. In handshake process, a machine usually sends packets to server saying, "Hey, I want to connect with you." And the server machine responds saying, "Okay, we can connect." The client responds saying, "Okay, connected." That TCP connection can be terminated by either of the machines. For example, you closing the browser. And if any machine takes more than a fixed amount of time, the connection can time out, causing TCP connections to terminate. TCP, however, lacks an easy-to-use framework that developers or software engineers like you and me can use to define meaningful communication channel. With TCP, you're just sending arbitrary data. This is where HTTP comes in, which introduces higher level of abstraction on top of TCP. It's just like developers don't code directly in assembly language, but higher level languages like Java. Developers don't write code to interact with TCP, but with HTTP protocol. This HTTP abstraction is a request response paradigm and lets developers to make client and servers communicate, which is why most modern day programming languages rely on HTTP protocol. Here is an example of sample HTTP GET request which a client can send to server, where one machine is sending a GET request and server is responding with an HTML file. As you can see, a simple HTTP GET request contains various parts. Here is a simplified example of how would you code GET request in JavaScript. Just like GET request, there are other types of HTTP requests such as post, put, delete, head, patch, and so on. On the internet today, the GET and POST methods are the one most commonly used. Oftentimes, the terms REST and HTTP are used interchangeably. However, REST is an architectural style for distributed systems, and HTTP is one type of network protocol that is set of rules for formatting and processing data. While it is not the same as REST, it exhibits many features of RESTful system.